Hey everyone, welcome back to the channel. Today we're going to build a powerful 1.4kW induction heater from scratch. This is a fascinating project that lets you heat metal objects without direct contact using electromagnetic induction. It's an amazing technology used in everything from industrial heating to DIY metalworking. So stick around as we go through the full process, from components to final testing. And of course, if you enjoy this content, make sure to like this video and subscribe to the channel for more awesome electronics projects. To start, let's go over the components we need for this induction heater. The key parts include a ZVS, zero voltage switching, driver circuit, high power MOSFETs like IRF-P260N, a high-frequency inductor coil made of thick copper wire, high-speed Schottky diodes, a powerful DC fan for cooling, and a high-wattage power supply capable of delivering around 36 V at 20A. We'll also need capacitors, specifically low ESR capacitors, to help smooth out the voltage, along with heat sinks to dissipate heat from the MOSFETs. Additionally, we'll use a ferrite core for better efficiency and some resistors and diodes to stabilize the circuit. The circuit board should be high quality, preferably a double-layer PCB to handle the high current flow efficiently. Now let's get to the assembly. First, we prepare the ZVS driver circuit, which is the heart of the induction heater. We begin by soldering the MOSFETs onto the board, making sure they are securely attached with their respective resistors. Then, we install the Schottky diodes to prevent reverse voltage spikes that could damage the circuit. Next, we add the low ESR capacitors in parallel to form a resonant tank circuit, which helps sustain oscillations in the coil. After this, we mount the heat sinks onto the MOSFETs using thermal paste to ensure proper heat dissipation. The DC fan is positioned strategically to blow cool air over the heat sinks and keep everything running smoothly. Once the main circuit is assembled, it's time to create the induction coil. We take thick copper tubing and wind it into a spiral coil, ensuring there are about 8-12 turns, with even spacing between them. This coil is then connected to the capacitor bank, forming the resonant LC circuit. To improve performance, we can also add a ferrite core inside the coil, which increases efficiency by directing the magnetic field more effectively. Now that our induction heater circuit is fully assembled, we move on to powering it up. We connect our high-power DC supply, ensuring the correct polarity. Before turning it on, we double-check all connections to avoid short circuits. Then, we gradually increase the voltage and observe the circuit's behavior. If everything is working correctly, the induction coil should start generating a strong electromagnetic field. To test it, we place a small metal object, such as a steel bolt, inside the coil. Within seconds, the metal begins to glow red hot due to the induced eddy currents heating it up. To optimize performance, we can fine-tune the circuit by adjusting the capacitor values or modifying the coil shape. If the system overheats, adding an extra cooling system, such as a larger fan or water cooling, can help maintain stability. We should also ensure that our power supply is delivering enough current without voltage drops. With everything running smoothly, our DIY 1.4kW induction heater is complete. This powerful device can be used for applications like melting metal, annealing steel, or even heating bolts for easy removal. It's a great example of how high-frequency electromagnetic fields can be harnessed for practical applications. So that's it for today's project. I hope you enjoyed this step-by-step guide on building a powerful induction heater. If you found this tutorial helpful, don't forget to hit the like button and subscribe to the channel for more exciting DIY projects. Let me know in the comments what you'd like to see next, and I'll be happy to make it happen. Thanks for watching and see you in the next video.